Hey, Katie.
Hi, Ben.
So you just got done running a marathon, or?
No, but I just got done running my Sunday long run, which is 14 miles this week. So that was
Oh my
kind of a
gosh.
killer.
I can't even run 1/10 that. So, well, I can barely run 1/10 that. I've been working on a home project. I feel like because we've both had some pretty intense weekends, we should digress from our normal pattern of talking about a topic in data science and instead do story time with Katie Malone. What do you think?
Sounds great.
All right, you are listening to Linear Digressions. Okay, so this is our first story time. What story are you gonna tell?
Well, so first we should say where we got the inspiration for this.
Oh yes, let's do that.
Okay. So this was a listener suggestion, and we get a lot of really good emails. This is maybe the best email we've ever gotten.
Yeah, it was so heartwarming and touching and made me cry.
No, it didn't. Did it really?
It made me kind of tear up a little bit, just a little bit.
Okay, just a little bit.
I don't have a problem
way.
with crying, but
Yeah.
No. I'm not a particularly manly man. But
This is an email from Jeff C. So thank you, Jeff. The original email was, "Hey guys, can you tell a good story about a time that I used machine learning to solve an interesting problem?" But then in the back and forth as a follow-up, he was saying how he listens to this podcast with his preteen daughter, I think, which is completely awesome and
that's incredible.
makes me just feel great about the world. So, Jeff C., if you're listening, I hope you are, and I definitely hope you're listening with your daughter, so that I can tell her how great her dad is. Anyway.
Oh no, you're gonna make me cry now.
Oh my gosh, Ben, keep it together.
Oh God, it's been a weekend, okay?
Okay, well, how about we talk about email mining and energy fraud, and maybe
That sounds great.
snap you out of
That
it.
sounds great.
Okay.
Energy fraud.
Yeah. So we had talked about I think in one of our earlier episodes, we talked about interesting data sets. We talked about the Enron emails data set.
Yeah, this was way back when we were, I think when we were in the first room that we were trying out when we were recording in the offices at Udacity, and it was super echoey, and it was a really early episode, I think.
Yes. And so that data set I have come to know and love because it was sort of the foundational data set for the Introduction to Machine Learning course that I was teaching at Udacity that I had just finished up at the time that we were starting this podcast. And so to give a little bit of backstory, when I was building this course for Udacity, the idea is that we want to teach about machine learning and data science. And there's many different things that you can talk about in machine learning and data science. And so having sort of like a season arc, so to speak, for the whole course is something that can help really tie it together, and it gives students
Definitely.
sort of a reason to pay attention to some of all these details because they become relevant downstream when you're trying to tie it all together into like one big, interesting, complicated, chewy problem.
Yeah, and ultimately the course was really fantastic. Of course, part of that was your fantastic skill. Part of that was also having a really good data set that is relatively, I guess you could apply a number of different approaches to it.
Yeah, so I had heard about the Enron data set. I had sort of known about it informally for a long time. It's one of these really famous data sets. And just to step back for a moment and tell this story.
Right.
So in around the turn of the millennium, like 2002 or so, as I recall, there was this gigantic energy company. It was called, well, it was energy and all kinds of other stuff. It was very strange. This huge company called Enron. It was something like the 10th biggest company in the United States at the time or something. It was gigantic.
Mm-hmm. Yeah.
And it had all kinds of very tight political connections, and they're just like gigantic amounts of money that this company was making. And to make a really long story short, there was a bunch of kind of dirty dealings that were going on inside, especially the very high levels of this company. So there was shady stuff that they were doing in the California energy market to kind of like cause all those. Do you remember those brownouts that were happening in California?
Yeah, I remember that. I grew up in California.
Yeah, that was Enron.
That
were
was
doing
Enron,
like
yeah.
weird things with the California energy grid to drive up energy prices and then sell things in just the right way.
Yeah, super sketchy.
They had this crazy. This was kind of like the last days of video rental stores like Blockbuster and Hollywood Video and stuff. this was, within a decade or so, Netflix would have taken over that market entirely. But they had this idea of using the internet to stream videos and have people like rent videos on the internet, which is basically what Netflix is. But they had this,
Right.
this kind of crazy idea to do Netflix like 10 years before anyone else did. And it never worked, but
This was Enron?
yeah.
This is wow. I didn't know that part of the story.
Oh, yeah.
So this is just crazy weird company.
Oh yeah, they were doing all kinds of stuff. And then there was
Kind of like maybe kind of like Amazon, if Amazon was like had an energy tie-in or something. I don't know.
It's definitely a company that's very hard to define exactly what it was they were doing, because they were just doing so many different things.
Right.
And a fair amount of what was going on was also just out and out fraud. There was a lot of kind of weird things that their CFO was doing to make it look like there were a bunch of, I'm trying to remember exactly. I think it was something like there were a bunch of assets that Enron held on its books that would have lowered the value of the company because they were like investments that Enron made that didn't pan out and things like that. And so their CFO cooked up this really crazy thing where he would create subsidiary companies of Enron, and then he would sell the bad assets to the subsidiary companies like right before a reporting period, so they didn't show up on the Enron books, but then would like buy them back because the shell companies weren't actually like meaningful independent entities from Enron itself.
Yeah, that's super shady.
And so, not surprisingly, the entire company ended up just, yes, surprisingly, but also not surprisingly, I guess, in retrospect. The entire company just ended up completely falling apart over the course of about a year. And all of the top people were implicated. So obviously the CFO, the chief operating officer, the CEO and president and chairman, and actually, I'm not sure if the COO did, but the CEO and the president of the company ended up in jail. And by my count, roughly 30 or so people total ended up going to jail or being indicted or having some fairly serious like legal consequences for their role in this. And many, many people lost their jobs, and there were pension funds all over the country that lost tons of money, and it was a mess. Okay, so that was the 2-minute introduction to Enron. So how is this relevant for machine learning? So what ended up happening was during the course of the federal investigation, they subpoenaed a bunch of emails that the people at Enron had been sending to each other. And those emails then entered like the congressional record or something like this. They basically became public in a way that no email trove ever like has been before or since. And probably in a way that, in all honesty, they maybe shouldn't have if we knew a little bit more. There were a lot of people.
Yeah, but this was early days, right? So we didn't know. First of all, we didn't know how much could be extracted from a data set like that. That wasn't necessarily explicitly in there. We also didn't really have many methods for anonymizing huge data sets like this.
Yeah, and that anonymization. I mean, there were lots of people who didn't do anything wrong, but their emails got kind of sucked up in this, and that's not good.
Right.
So, but those emails are sort of part of. They're in the wild now, and they've been studied from many different angles to give us ideas about how do people communicate in complex organizations. What is the what can we learn about how women are represented at the upper levels of these gigantic corporations? What was the social network structure like? All kinds of interesting things you can ask with a data set like this. And so this is a super cool data set, and obviously like publicly available. And there's a lot of resources out there and a lot of background information that you can find out about Enron just from Googling, which is basically how I know all the things that I know about it. So I knew that this data set seemed pretty cool. It's about 400,000 emails, and then it's organized. Once you get the data set, it's organized by sort of mailbox, so to speak. So you get in there, and there's 100 or so, 150 folders, and each one of them is the name of a person. And then within that folder, you find a bunch of emails like to that person. And there are some kind of big fish in there that you can find. Like they have Kenneth Lay, they have Jeff Skilling, I don't think they
These are the people who went to jail?
Yeah, Ken Lay was the president of the board and like chairman. The Jeff
Right.
Skilling was the CEO. Andrew Fastow was the CFO, the guy who was doing this weird shell company thing. His emails were not. There wasn't like a folder named Andy Fastow. But that's roughly the structure of the data set.
Right. So, like, a very naive approach of trying to figure out what happened would just be to look at the people who went to jail and look at their folders and kind of study those emails. But that wouldn't really paint an entire, like, whole picture of what was going on, or some of the other correspondences between people who were involved in shady stuff but didn't end up going to jail.
Yeah. So, and just to step back for a second, like the thing that I was interested in trying to do, I thought about it for a while, what I wanted to do with this data set. And yeah, so one of the ideas I had was, are there patterns in who people are sending emails to and or what they're talking about that help us distinguish the accounts that are associated with what we ended up calling like persons of interest? So people ended up either, what was our definition of a person of interest? It was a person who went to jail or was indicted or testified in exchange for prosecutorial immunity. So basically people who legally were somehow implicated in the fraud.
Got it.
And so is there something in the emails that those people were sending or receiving that distinguish them from the mass of the company as a whole, which we presume is by and large ignorant of the fraud and is innocent? And then, but there, you could imagine that like the 30 or 35 people who ended up being sort of persons of interest might not be every single person who was perhaps involved in what was going on here. So there was a little bit of like fuzziness about what the actual labels should be. But the idea was, let's see if we can turn this into a supervised classification problem where the emails are somehow the features that we have available to us. And then the labels that we want to find out are, was this person a person of interest in the legal case?
So what were the steps involved in taking this data set and preparing it for this course, basically?
Yeah, so the first big one is something you already mentioned, which is that the number of the persons of interest that list doesn't map on very cleanly to the subfolders within the Enron data set.
Ah, I see.
So
were you going through and like cleaning this data set up so that way it's a little bit more easy to work with?
Yeah, so you have to like completely reformat it in some ways. Yeah, so I have this kind of hand curated list of 30 or 35 people who are my persons of interest. I have another, I'm trying to remember, I think 100 or so people that I have their email boxes. There's only overlap of less than 10 people between those two lists. And so I'm like, well, we can't really do this if we only have 10 people, 10 examples of persons of interest in here that we have their emails. The thing and the emails are just in plain text. So what it sort of looks like when you get in there and you start looking at the emails is each email is a file. They just have it's like a number, 1.txt, 2.txt, 3.txt, and each one of those is an email. And then inside the file, there's going to be the to line and the from line and the BCC line. And then there's going to be the text of the message. And there's a couple of, the date. There's some other metadata. But the first thing that I was thinking about was let's take the example of Andrew Fastow. I know I don't have Andrew Fastow's email inbox, but I still would be really interested in seeing the emails that are associated with his account.
So some people may have sent emails to him or gotten emails from him, and it might be in other people's accounts.
Exactly. So what I have to do is I have to comb through all of the emails, and I have to see, do we have messages that were either from him or to him, but that are, or where he's CC'd on them, where they're showing up in somebody else's box. So you have to ask that question of basically everyone. And when I say reformat it, that's what I kind of mean, is that we go through and we make a big list of everyone that we have in the entire data set, all the people who are sending emails, all the people who are receiving emails, and then what emails map onto those senders and to those recipients. And then we also had, like I said, CCs as well. So then you have this big long list of all the email addresses that are in this data set. and then the emails that sort of are matched up with them. And you also have potentially the text of the messages as well, but I hadn't gotten to that point yet. And as we've talked about, text analysis can actually be pretty powerful if you want to do something like tell the difference between two authors, like supervised classification can actually do.
We talked about Satoshi Nakamoto, I think, the Bitcoin guy. We talked about J.K. Rowling. We've talked about a number of those.
Oh, you forgot the best one.
Oh, what was the best one?
Alexander Hamilton. We talked about the Federalist Papers. Yeah.
Of course, the Federalist Papers.
And the star of my new favorite Broadway musical of all time.
Yes, I'm excited about it too.
Yeah, it's coming to Chicago. I'm pumped.
I got season tickets just because I had to. Okay, let's not go down this road.
Wait, you can get season tickets for Hamilton?
You can get so.
That doesn't make any sense.
So in the area where I live in San Jose, I think I don't remember if it's San Jose or if it's San Francisco. I think it's coming in San Francisco. But in order to be guaranteed to get Hamilton tickets in San Francisco, you have to get season tickets.
Oh.
That's the way they get you.
I see.
And so they got me.
Yeah, so in Chicago, what I've heard is that the pre-sale is just for groups, but I work at a company that has a lot of theater nerds in it, or and also government nerds. And so it was really easy to find 20 people who wanted to go see him. Anyway, back on track. So text analysis of, let's say, like the actual words that people are using in the messages, like that would be on the table here potentially.
That seems like a relatively simple thing to do too. It's just, I mean, a simple naive analysis would be you count up the different words that are used and you look at how frequently they use certain words versus other words.
Yeah, so there were a few things that seemed kind of not great about that right off the bat. If we were going to be doing it by, we'll say, let's organize it by like author. So according to like when people are authoring emails to other people, what are the things that they're writing about? And so one of the things is that there were wildly different numbers of emails that we had associated with the different accounts. So we had lots and lots of people that we only had one or two emails to and from them.
Not statistically significant.
Yeah, and then the far end of the tail, you had the most populous ones were more than 10,000. So it was a little bit hard to know the best way to like normalize that. And keep in mind, I was doing this as sort of an example project for students in the Udacity course who presumably this is their first exposure to machine learning. So you don't want to do anything that's like totally crazy and weird.
Yeah. So you're basically making a sample project and then you make instructions for them. Like, this is what you want to do first. Then maybe you want to try this or this or this. And then the goal is for all of the students to be able to do the project that you made a sample project for.
Yeah. So then I was like, well, what if we think of like my guess, and this is not supported by any research, but this is a guess, is that maybe like the text, the words that people are using when they're communicating is not as important for answering this question as just who they're talking to in the first place.
I see.
And so what if I think about this, I still can think about this as a text analysis program, but to kind of keep things under control a little bit, instead of looking at the words that they're using in the message, what if I look at every time they send an email to someone, I have that email address, right? And so we think of all of those email addresses as kind of like a vocabulary, and then the words that I use are all the email addresses that I'm corresponding with, and it's the same. Then you can use all the same infrastructure.
So instead of counting words, you're counting email addresses that you see them send a message to.
Yeah, but you can use all the same packages and stuff, so it still like works pretty nicely.
So you don't have to write all this from scratch. You can use all of the
scikit-learn and NLTK. Yeah,
most of the
scikit-learn. Yeah. So it's like, okay, sweet. So what I need to do is I'm gonna start to look at the emails that people are sending to and from other people. Even then, like treating it as a text analysis problem was starting to get like a little bit too heavy-handed for my laptop, to be completely honest. And so I was like, okay, so let's make this even just a little bit simpler. Let's try to make an aggregated statistic for each person instead of having like this big long list of the vectorized counts of who they send all the emails to and blah, 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 to make this a little more intuitive, what if we just figure out how many emails they send to a person of interest, how many they receive from a person of interest, and how many are they joint CC'd with a person of interest. And you count this up over all the persons of interest that someone might be interacting with. And so then you start to get, and you can get the raw count, and then you can also normalize it by like the total email volume of this person. And so then you start to get an idea of just whether they're interacting like very frequently with persons of interest, or if they seem to be just not speaking with them at all. Which is now we're wondering like a little bit, it's changing the interpretation of what we're saying a little bit. What we're starting to say is like we're looking for features like that people are interacting with persons of interest instead of they're using the same words as person of interest, and you might end up getting slightly different answers for those two things. For example, maybe the number one person who interacts with Kenneth Lay is his secretary, and she's probably not really involved in this. But again, it's sort of like bringing this a little bit under control so that we can start to move towards something that looks like a supervised learning problem.
You know what's really unique about this process or this project is that you're not taking all of the tools out of your toolbox and using any tool you want. In this particular project, you're trying to use the simplest tools because the project that you're doing is ultimately for beginners to do. And those beginners are going to have a much more limited tool set, both in terms of what they know how to use and what they also conceptually understand and would think to possibly apply. So it's kind of an unusual problem.
Yeah, I mean, I think that a lot of the algorithms that you use in machine learning, like they were designed with certain use cases in mind sometimes, but once you start to get to know the algorithms very well and you know the data set and what you're trying to do with it, then a lot of the, sort of artistry of machine learning is figuring out how to find the tool that's gonna fit the problem that you have, even if it doesn't map onto it like sort of perfectly in a textbook way. But so now I had sort of reduced I started out with this big sprawling like email text classification problem, and now it had turned into like a bunch of labels, and then the feature space was like, I don't know, at this point like 7 columns or something. It's like the number of emails that you receive from a person of interest, the number of emails that you send to a person of interest, and it's collapsed down so much that it's hard to tell if we're even going to be able to get anything useful out. So then I'm kind of reading about Enron in my spare time because I'm just like fascinated by it at this point. I'm digging up all these news articles from 2001. I read this one article about something about like you're not going to believe how much of a bonus these Enron guys were getting, last year when the company was falling apart. And I was like, oh, interesting. And in the course of reading the article, it became clear that whoever the reporter was for this article had seen a list that had been entered into the congressional record and had been like part of the congressional testimony for the previous day. And there was a list of all of these people at Enron and how much money they had made and how much money they had made in like a bunch of different categories. So their salary, their bonus, a bunch of different kinds of like stock options, whether they get reimbursed for travel. I'm probably forgetting some of these things.
Yeah.
And I'm like, that sounds very interesting, because now this is like a completely different type of data. This is money data that if you can find a way to merge it in with the email data, then you have sort of two handles on this problem at the same time. I don't know how easy that merge is going to be, and I don't know what it's going to look like, but like I want to go find this data set and see if I can try to like make that join, because then we have just an entirely different picture of what might be going on here. So I forget how exactly, but some kind of magical Google foo, I found this spreadsheet.
Google foo.
Yeah.
Google foo that's where it's at.
Yeah.
That's the best skill.
I found this spreadsheet. It was like a PDF on some government transparency website, which then I had to find one of those tools that like converts a PDF into a Google spreadsheet so that then you can start to actually turn it into a table. And so this list has on it, I think, 150 or so people. It has basically all of the persons of interest. So I was like, okay, great. So I have money information for all the persons of interest. And there's a fairly tricky little operation now that I have to do to join in the email data, because the email data is sort of indexed by email address. and this financial information is indexed by name. And lucky for me, Enron has kind of a convention in the way that their email addresses are assigned, where it's usually like first name, last name at enron.com. So for a lot of them, you could sort of go through the financial information. You could pull out the name, just concatenate the first name and last name, and look for something that looks like that in your emails database. And that actually works for most of them. There were a bunch of stragglers that I had to go in and get by hand, like people whose real name might be William, but their Enron email address is like Bill, whatever. Also, sometimes you have two people with the same name, and you have to figure out, one of them might be...
Which is which.
Yeah, one of them might be a secretary. The other one is a vice president. And so from this, I have a bunch of information about who the shareholders are, who the vice presidents are, who's making tons of money. And then that was a much more interesting data set to actually try to do this classification problem with. And it turns out that I was playing then with a bunch of different supervised classification algorithms, where the inputs are how much money people are making and also sort of these email patterns. And it turned out that the money is actually much more correlated with whether you were a person of interest than the emails ever were. So I put all this work and all this like great inspiration from the email addresses, and then it turns out it's basically just money. But I never would have found the money if I hadn't been, thinking about these emails so carefully.
Yeah.
And so that's basically where the story ends. Like I said, this was a project for the Udacity students to go through, not necessarily with any heavy-handed interpretation at the back end about who may or may not have been a person of interest in the Enron case. It was more an experience of sort of going through and thinking about this problem. What's the classification algorithm you want to throw at it? What are some of the performance metrics? Making sure you can set up your cross-validation, like all these other things that are just sort of I'm glossing over right now, but they're really important for especially first-time students to get them all set up correctly. But we wanted to make sure that like the data was in a reasonably good format for a student to be able to do this exercise. So obviously that meant that there was a lot of work on my part, which maybe now thinking back, I appreciate even more than I did at the time, I think. So yeah, that's the story of how we found fraud at Enron. I don't know, not really. That's not a fair statement, but
yeah, we weren't the ones who found the fraud.
Oh yeah, no, not by a long shot. But I read a lot of people's emails, and some of them were interesting. Most of them were boring, but some of them were fun.
What one interesting thing about this is I think when we first did an episode about this, and we didn't go into this much detail, but you said that this was an unprecedented data set. And I think we ended the episode with something like, you said, like, we're probably never going to get another data set like this. And then I think it was maybe a couple months after that, not all that long after that. And then the whole Sony hack thing happened. Mm-hmm. And then all of these emails were leaked out there. Now, these were not entered into a congressional record. They weren't legally leaked. But definitely this humongous corpus of emails from Sony execs and everything is indeed out there. So we'll probably continue to see data sets like this as companies get hacked, but we'll probably never see this again through any kind of legal channels, because now we know enough to know that, releasing these emails into the public is not a good idea because of how much data you can pull out of it that's not necessarily apparent.
Yeah, I think the one thing the other place where big banks of emails do come out fairly frequently. It's just that it's a controlled release that's being done by the person who has the emails, and so they're sort of like being released voluntarily in a sense. So the things I'm thinking of in particular when I say this are like Jeb Bush, when he started running for president, had many years worth of correspondence that he had when he was governor of Florida, and he decided to release all of those emails as sort of an exercise in transparency and to show what a good leader he was and what a good executive. And so he actually published like all of those emails on his website, and ended up taking them down eventually because there were some personally identifiable information in there, so they didn't even do a particularly good job of scrubbing them. But those data sets, when you find them, they can be fairly interesting, but you just have to keep in mind that this is the data that someone has decided it's okay for me to see, and that then there's always like a slightly different way you have to think about that than like, oh, this is just like this data, this is all the data that there is, and this isn't like a controlled release.
Linear Digressions is a Creative Commons endeavor, which means you can share or use it any way you like. Just tell them we said hi. To find out more about this or any other episode of Linear Digressions, go to lineardigressions.com. And if you like this podcast, go ahead and leave us a review on iTunes so other people get to listen to this content too. You can always get in touch with either of us. Our emails are ben@lineardigressions.com and katie@lineardigressions.com in case you have comments or suggestions for future shows. You can tweet us at lindigressions. Thank you for joining us, and we'll see you next time.